Hello everyone and welcome to my presentation on backward design and Bloom's taxonomy for learning. So first, what is the backwards design? It emphasizes planning instruction with primarily keeping the end goals in mind. It consists of three different stages. First is identifying desired results. So it's important to set learning goals by reviewing content standards, whether that's national, state, or district, and curriculum expectations. These are prioritized content due to limited instruction time and selecting the most important topics. Next, you clarify learning priorities based on long term performance goals, focusing on what students should be able to do within their learning in various contexts. Also, emphasize the transfer of learning, ensuring that students can apply the knowledge and skills beyond the classroom. And finally, engaging students with essential questions that promote deeper understanding and support transfer of learning. An example of this I use throughout the presentation for backwards design is in mathematics. So the transfer goal, they will be able to apply their reasoning to real world problems, ensuring understanding that they can represent it in multiple forms, whether it's numerically, graphically, or symbolically. The essential question: what's the best way to represent this idea? How can it be represented in other ways? And the key knowledge and skill being that they can understand different ways to represent data and solve problems using different approaches. In stage two of backward design, we think like assessors. Before planning lessons, make sure that the aligning assessment has the desired results that we found in stage one. We need to determine assessment evidence needed in order to validate that the target learning has been achieved. And through this, you can use different kinds of assessment. Performance tasks to assess their ability to apply new learning to authentic situations, and other evidence like quizzes, tests, and observations. And assessing understanding through the six facets: explanation, interpretation, application, perspective, empathy, and self knowledge. Using performance tasks as culminating assessments rather than daily tasks is important because within the lessons you can be building towards them instead of just assessing at the end. Stage two example, again, keeping with the mindset of mathematics, a performance task would look like a real world problem. For example, if I were to have students plan a budget for a school event and have them represent their solution in different math formats, such as graphs, tables, equations, and they can choose explain why they chose each representation and how it helps solve the problem. Other evidence would look like a homework assignment where students practice converting data into different representations. And finally, stage three of the backwards design: planning, learning experiences, and instruction. You're planning lessons and activities to address three types of goals from stage one: transfer, which is applying learning in new contexts; meaning making, constructing understanding and making inferences; and acquisition, acquiring knowledge and skills. When coding activities with T, M, and A, you do that to ensure all goals are covered, avoiding focusing solely on information presented and basic skill acquisition. Support understanding by providing for students to make those inferences and generalizations, and encourage transfer by allowing students to apply learning in new situations with timely feedback for improvement. In this, you shift a teacher's role from a quote unquote sage on the stage to a facilitator and coach, guiding meaning making and transfer. And the example with that, continuing with the mathematics example, You transfer new learning by providing students with complex real world problems that require them to choose the most effective way to represent their data. Teachers will offer guidance and feedback as they work through the task. Students independently solve the problem, creating multiple representations, explaining their choices in a written report, and assessing their work through the final performance task, and providing individualized feedback. Meaning making. You facilitate teaching by encouraging them different ways to represent the same data, using questioning techniques to prompt the students to think about why one might be more effective than another in any given context. Students work on problem based learning tasks, comparing different data representations, and discussing effectiveness in small group discussions. Using student reflections and group discussions, you can assess their understanding of the material. Lastly, is acquisition. Um, Through direct instruction, you can teach students how to represent data using graphs, equations, and tables. Students practice converting the numerical data into those small groups and with teacher support as needed. You can use a quick formative assessment like an exit ticket to gauge student understanding of data representation. Now, having seen how the backwards design can be helpful in educational setting, let's look at what is Bloom's taxonomy. Benjamin Bloom created this framework in 1956 along with other educational contributors, and it has been used by teachers and colleges worldwide in the K to 12 educational system. Why use Bloom's taxonomy? Well, it's a guide for educators that really allows us to identify goals of students at varying levels and creating plans in order for them to achieve them. Starting out with level one, remember, at this level, students are expected to show that they remember previous knowledge gained. This is the simplest level, such as recalling main character's name or listing key events. You can see teachers can begin asking questions using words like list, define, match, identify. Next is understanding. At this level, students are expected to show the meaning of information by interpreting, explaining, or summarizing concepts, like summarizing the main idea of a chapter or explaining a theme in your own words. In level three, students are ready to apply the new knowledge gained through words or actions. This could come across in making a prediction from the story or applying a character's decision making process to a real world situation. Words like demonstrate, prepare, produce, or solve would be seen in this context. Level four, analyze. At this level, students are ready to ask why or how this information is relevant to themselves or society in general. For example, breaking down the author's use of what a symbol might mean in a novel or comparing and contrasting characters within a story. Level five, evaluate. Level five, evaluate. At this level, students are ready to form their own judgments on new knowledge gained and how they might relate this knowledge to benefit both inside and outside their classroom. An example of this would be judging an author's argument in a persuasive essay or figuring out the credibility of sources used in a nonfiction text. And lastly, create. At this level, students are ready to use their critical thinking skills to create ways to show how they've benefited from new knowledge gained. Students could write an alternative ending to a story, create a new character, and put them into the plot as it already exists. Backwards design starts with aligning instruction with clear goals and meaningful assessment. And Bloom's taxonomy helps educators design activities and assessments through addressing different cognitive processes. By combining these two frameworks, educators can create a structured and purposeful curriculum that covers a range of cognitive levels, ensuring that students achieve well rounded learning outcomes. Thank you so much for listening, and I hope you had at least one good takeaway from my presentation.